Okay, so we're talking about area and perimeter of all the different special types of quadrilaterals. First of all, we've done area before. We did area of triangles before. We did area of circles before. You've done area of all of these shapes probably before. So area is just the amount of space inside a two-dimensional figure. Now I have space in quotes because space is really a word that's usually used to represent like three-dimensional space. So it's not really space inside a figure. It's more, a better definition would be the amount or the number of, okay, so the number of square units that can cover a two-dimensional figure is really a better way of thinking about area. But usually this is what people say when I say what's area, the space inside. So that's fine. Just remember that we're talking about two dimensions. Perimeter is just the distance around. We've done that before, right? So you just add up all the sides. Okay, again, we're just going to be mostly focusing on area. So the first page of this notes has all of the area formulas listed all in one location, all the different quadrilaterals. Then as we go through the packet, we're going to kind of take them one at a time and sort of see how they work and practice them. But they're all listed on the front. So rectangles and parallelograms both have the same formula, and that is area equals base times height. Or you might have heard length times width, but same idea. Parallelogram, same area. Square is also base times height, but remember with a square, the base and the height are the same. So sometimes it's referred to, the two sides are both called S, and then base times height would be side times side. So that's just S squared. So sometimes you might see area of a square written as S squared. So even though a rectangle and a parallelogram look different, right? You can think of this rectangle, this original rectangle, being turned into a parallelogram just by moving this over to here, right? So take the parallelogram, turn it into a rectangle, or vice versa. So the base and the height, the important thing is that they're always perpendicular to each other. You're not using the slanty side of the parallelogram. Okay, and then trapezoid formula is a little more complicated, but just as easy to use. 1/2 height, and then there's two bases, because of a trapezoid, the two parallel sides are called the bases. So 1/2 height times B1 plus B2. Okay, so I'm just going to highlight this here because we're going to keep saying this over and over. Base and height always have to be perpendicular to each other. So they form a right angle. And you'll see as we go through that how important that is. Okay, so rhombus and kite have the same area formula, and that is 1/2 D1 times D2, where D1 and D2 are the lengths of the two diagonals. So are the two diagonals in a rhombus the same length? In a rhombus, no. Parallelograms, no, right? Kites, no. Right? The only time the diagonals are the same length, well, square, rectangle, right? And a square because it's a rectangle. There was one other shape we learned just last class. What kind of a trapezoid? Isosceles trapezoids have congruent diagonals also. Okay, but that's just a side note. This formula, 1/2 D1 times D2, you're expecting the D1 and the D2 to be different lengths with a rhombus and a kite. Okay, so this is just review here. the area of a triangle is not on this list, obviously, because it's not a quadrilateral. But how do we find the area of a triangle? Yep, Cooper. Good. So BH over 2, or 1/2 BH. And then notice it was the same story with triangles. The base and the height had to be perpendicular to each other. So we look for that altitude down, and this formula would just be 1/2 times base is 9 and height is 8. Remember, area is square units. This one is a parallelogram, and you can see up above on this page here, area of a parallelogram is base times height. But again, this diagram is just emphasizing that the base and the height have to be perpendicular to each other. So what would the area be? 64, 8 times 8. Okay, so let's look at the breakdown now. We're going to take a few at a time. We'll start with base times height. So that covers rectangles and parallelograms. Again, base is always perpendicular to the height. Okay, it's important to remember that. So when you look at number 1 here, 1A, in this diagram, I'd like you to try to find the area using base times height, keeping in mind that the base is always the length of one of the sides. The base is always the length of one of the sides, and the height is always perpendicular to that base. So try to find the area in number 1A, please. Okay, so I just added this right here. The base is always one of the sides of the figure. So it's important to remember that the B represents one of the sides, but the H doesn't necessarily represent one of the sides. The H has to be perpendicular to whatever that B was. Okay, so in this diagram, what would be the two numbers you would multiply together? What would be your B and H? What did you use? Yep, 15.1 and 7. 15.1 is the length of one of the sides, and the 7 is the height that's perpendicular to that, so always look for that right angle. 14.9 we can't use in this one because we don't have anything perpendicular to it. All right, try B. Okay, for this one, what are we going to use as our base and height? 3.5 and 2. Base is 2 and height is 3.5. Why? Because the base is always one of the sides of the figure. Is this piece one of the sides of the figure? No, so we're not going to use that length of 3 at all. We're going to use the 2. 2 is the length of the side of the parallelogram, and if we extend that side, you remember we did this with triangles before. Sometimes the height has to be drawn kind of outside of the figure. So 2 is the base, and if we like climb up here and drop a height down, it's the 3.5. So 2 and 3.5 are the base and height. Any questions on that? So just be careful of those two things. Okay, so let's practice that a little bit. In this parallelogram, any one of the bases, any one of the sides can be used as a base. Base does not mean bottom in geometry terms, okay? Base is just one of the sides. So if I want to use this as my base, this green that I highlighted as my base, and I want to draw a height from this dot that's provided there, what you need to do is start at that dot and draw a height, maybe a dotted line, perpendicular to the green base. So try to do that. So you should just draw straight down like that, perpendicular. It's perpendicular to both bases actually, right? If it's perpendicular to one, it's got to be perpendicular to the other one if the bases are parallel. Okay, so that's one of the combinations of base and height for this particular parallelogram. We've got this base and that red height. Now, if I highlight this one as the base, now I want to use that side. Remember, B is always one of the length of one of the sides. So now I want to use that blue one as my base. What I want you to do is start at this point and draw a height from that point perpendicular to that base. So I have a question. Could this possibly go through the parallelogram? Inside of it? It's impossible to go inside because when I go like this, there's no way I'm going to get a right angle there. So it's going to have to go outside of the parallelogram. So you might want to extend this side. Extend that side. Now think about starting at this point and dropping an altitude basically down, a height that's perpendicular to that base. So try to do that. Okay, so I know that this one visually is a little bit harder to draw, but think back again to this shape that we had here, right? We used the 2 as the base, and that base basically had to be extended this way, and then if you imagine climbing up here and dropping a height down, that's kind of what we're doing here. We extended this, so if you want to turn your paper so that this looks like it's the bottom of the parallelogram, and then the height would be here. That's really what we're doing, okay? Because when you have the base in one direction, it's going to have its own height, separate and different from in the other direction. So some of you drew, you did this. And that's a height, but it's the same height as this one. And it's perpendicular to that same side. So we wanted to make something perpendicular to the other side, so that's why we had to turn it here. Okay. All right, so I'm going to go off the paper a little bit here. If I draw a parallelogram then, and I tell you that this side is 12, and this is 2, what's the area? 24. Base times height, 12 times 2. Those are perpendicular to each other. So now, if I tell you that this side is 3, and I want to use that as my base, what I need is a perpendicular here, right, to use as my height. Something that's perpendicular to the 3 I need as my height. What would be the length of that? How do we get 8? Cooper? Yeah, because if you have base times height in one direction, and it gets you the area, then when you use base times height in the other direction, it should still give you the same area, right? It's the same shape. You can't have a different area. So for this problem here, we did 12 times 2, we got 24. Well, in the other direction, the length of the side was 3, and we weren't sure what the height was. Well, the only way to get 24 is if height is 8. So that's what this next little piece of the notes is talking about. if they give you the base and height in one direction, and they have something missing in the other direction, you should be able to solve it based on the fact that the area is going to be the same either way you calculate it. So if we fill this in a little bit, give me in this diagram, what would be a base and a height, two numbers that will multiply together to give me an accurate area, keeping in mind that base and height are perpendicular to each other. What two numbers could we use? Yeah, Delphi. 13 and 9, exactly. So 13 times 9 will give us our area. And what's that? I think it's, yeah, it's 117. Okay, so now we know the area is 117. Well, let's do base and height in the other direction. I already used 13 as a base. Remember, base is always one of the lengths of the side. So what do I have to use as my base this time? 9.4. And then the h is what's missing. This we could call h. So you're basically going to solve 117 equals 9.4 h. Divide 117 by h. By 9.4. And we get h. 12.45. inches. All right, so we're going to do the same thing here. Base times height equals base times height. Remember, base is the length of one of the sides, so we're going to put the two sides in for bases. What are the two sides? What are my two bases, in other words? 4 and 16. Right? Those are the two bases, because the bases are the lengths of the sides. If I use 16 as my base, what am I going to use as my height? H. Good. If I use 4 as my base, what am I going to use as my height? So now this is 16h equals 36, and we solve for h. And we get 2.25. And that's just height, so it's meters, not square meters. All right, try number 3. All right, so what'd you get for number 3? What'd you get for number 3? 3.5. Good. You should have the two bases are 5 and 14. If you use 5 as your base, what's perpendicular to 5? 9.8. And what's perpendicular to 14? H. So H should be 3.5 miles. All right, any questions on that? All right, so these last few formulas here, rhombus and kite have the same formula. 1/2 d1 times d2, diagonal 1 times diagonal 2. So it's the length of the diagonals. So if I want to do this problem here, I'm going to say, well, what's d1 and what's d2? So assuming that this is pointing just to this piece here, so that piece is 25. What's the whole diagonal? 50. Because in a parallelogram, diagonals bisect each other, right? So if that's 25, this has to be 25. So in the other direction, they give us that little piece is 22. So what's the whole diagonal? 44. So based on our formula, 1/2 d1 d2, and this is multiplication. Be careful here. One of the mistakes I find that people make on this test is they do D1 plus D2 because they get it confused with like trapezoid or whatever. So this is all multiplication. D1 times D2 times a half. So it's more like base times height than anything else. D1 times D2. So this comes out to 1,100 square feet. Okay, so for number 5, again, we want to figure out what D1 and D2 are. Based on what they labeled here, what would one of the diagonal lengths be? 8. That's 4. This must be 4. How are we going to get the other diagonal? Kelsey? Pythagorean theorem. Isn't that lovely? How do you know that those are right angles? Because it's a rhombus, and one of the special properties of a rhombus is that diagonals are perpendicular, right? So we have this right triangle that we can pull out right here, where this is a 4. We'll call this x, and this side is 6. So Pythagorean theorem, 4 squared plus x squared equals 36, or 6 squared. And then x squared equals 20. Is that 16? X is the square root of 20. How do I simplify the radical square root of 20? What's a perfect square that goes into 20? 4 and 5. So this is 2 root 5. So x is 2 root 5. That's from here to here. It's 2 root 5. What would the whole diagonal be? 4 root 5. Right? 2 root 5 and another 2 root 5 would be 4 root 5. Okay, so our area then, 1/2 D1 D2 is 1/2 8 times 4 root 5. So the exact area would be 16 root 5, and the approximation of that as a decimal would be 35.78. And this is square meters. So keep in mind that with rhombuses, perpendicular diagonals make it right triangles, and we might be needing Pythagorean theorem for that. Okay, trapezoids. Area is 1/2 height times b1 plus b2. So this is still 1/2 times a number times another number. You have to remember that because of order of operations, b1 plus b2, the sum, you have to do that first. So you get a number there. So then it's 1/2 times base times whatever the sum of those two bases are. Remember, the bases are always the parallel sides. Even if this is turned in a different direction, the bases are still the parallel sides. So we're just going to follow this formula. 1/2 height, b1 plus b2. What's the height of this particular example here? What's the height? 10. And then we're just going to do b1 plus b2 is 16 plus 9. So we have 1/2 of 10 plus 25. Once you get it to this point where it's just, there's no addition anymore, it's all multiplication, it doesn't matter when you do the 1/2. And you can also think of it as just being over 2, right? Either one is correct. So I could do 1/2 of 10, and I get 5 times 25. Or I can do 10 times 25 first and get 250, and then take 1/2 of that. It's still 125 square feet. All right, you guys try number 8. and 9. Let's do 8 and 9. So, you guys, like I've mentioned, the rest of the year, really, in this course has all formulas. It's all formulas. And the important thing is when you are showing your work on your tests or quizzes or the final exam, you want to make sure that you are showing me what you plugged into your formulas. Don't just say I did it on the calculator and put down an answer. All right? That's not going to get you any partial credit. In fact, even if you have the right answer, that won't even get you full credit. It will take off if you don't show me the formula. So even if you don't write out the formula itself, I should see all of the parts filled in. So you can see how I wrote it here. And here I'm going to say area is 1/2, and now I'm going to put in my height. What's my height? 7.5, and then I'm going to do 9 plus 22. Even if you just write that and then put the answer, because you do the rest in your calculator, that's fine. You don't have to show me every single step. But I need to see the loaded in, the filled in formula, okay? So that I can tell what you did. Now, this is for credit on the test, but it's also because, like, on your homework, you should still do this on your homework. Even though it's not being turned in for a grade, right? You should still do this, because if you get something wrong, it's so much easier to find where your mistake was if you have that at least filled in. Then if it's wrong, even though you filled it in right, then maybe you just push something wrong on your calculator. But if you have it filled in wrong, then I can look and be like, ah, you used the wrong thing for your height or whatever, right? So it's much easier to find mistakes if you show all of that, okay? All right, so this one should have been 116.25 square meters. What's the height in this one? 7. And the two bases are 13 and 4. So this one turned out to be 59.5 square yards. Any questions on that? Okay, so what about kites? Kite has the same formula as a rhombus, 1/2 d1 times d2. What do kites and rhombuses have in common as far as their diagonals go? They're both perpendicular. So again, with a kite, we have all right angles being formed here. So there's right triangles. So again, maybe some Pythagorean theorem might happen. Anything with right triangles is possible. Pretty straightforward formula. 1/2 d1 d2. Let's do number 11 first. They literally tell you the two diagonals. It couldn't get any easier. 1/2 12 times 3. So half of 12 times 3 is 18 square feet. But let's look at number 10. Oops, D1 and D2. If I call the longer diagonal D1, how long is that? 15. So notice sometimes they write things separately here. You want to add them together to get the whole length. So D1 is 15. What's D2? 12, because it's 6 plus 6. So our formula then is 1/2 15 times 12, which is 90 meters, square meters. Okay, any questions on that? All right, so let's look at the back page. What if we have a figure that doesn't have a formula? So, in other words, like, not everything in life is perfect polygons, right? What if I wanted to pave my driveway and I wanted to figure out, estimate the cost of that, you know, and maybe my driveway has like a odd shape. Maybe I want to carpet my room, and my room has a really odd shape. It's like, it has a little alcove like this, and then it goes like this, or something like that, right? What would I do? Yeah, what do you think? Ethan, what do you think? Yeah. But how, without a formula, okay, so you're saying you would do this piece separate from this piece? Okay. Basically, that's what you have to do. You have to separate things into pieces that do have formulas. And then once you get the area of the separate pieces, add them together, right? So now this one's not a polygon. Why is it not a polygon? A circle. Right. Anything with a curve isn't really considered a polygon, but we still could find an area of this irregular figure because we know how to find the area of a circle, right? So we would just take the area of the separate pieces. Let's do one of them, or maybe a couple of them. A couple minutes. Okay, so here we're going to do the triangle. And so for the area of a triangle, we need 1/2 base times height. What's the base of this triangle? 6, because this is a square and all the sides are 6. So 1/2, 6 times, what's the height? 8, because it's perpendicular to the 6, right? So 6 times 8 is 48, divided by 2 is 24. So we've got the area of this triangle here is 24. Now let's do the area of the square on the bottom. If each side is 6, what's the area? 36. How are we going to get the area of the whole shape? 4 plus 36 equals 60. So 60 square inches. Again, anything like this, you're going to want to show all your steps, label things carefully so that I can sort of follow what you're doing and that you can follow what you're doing. All right, here we have a half a circle and a rectangle. What's the area of a circle? Pi r squared. And we have to cut it in half because it's half a circle. So what's the radius? 4. So 4 squared is 16. So we have 16 pi over 2, or 8 pi. So the area of this circle, half a circle, is 8 pi. We'll turn that into a decimal later. Rectangle, area is just base times height. So what are we going to do? 12 times 9. And what's 12 times 9? So now the area of the whole thing is 8 pi plus 108. So basically, we need to figure out what 8 pi is, which is about 25.13 plus 108 gives you 133.13 square inches. Okay, so that's basically what you would do with odd shapes. We'll finish this another time.